Look at your hand. It feels immediate, present, here. But between the light leaving your skin and the image forming in your mind, time has passed. Not much. A few thousandths of a second, perhaps. But it has passed. The hand you see is not the hand that exists now. It is the hand that existed a moment ago, already gone by the time you became aware of it. This is not a metaphor. It is a fact about the structure of experience. Everything you perceive, every sight, every sound, every sensation, arrives after a delay. Some delays are short, others are incomprehensibly long. But there is always a gap between an event and your awareness of it. Reality does not rush to meet you. It takes its time. Start with something simple. You are sitting in a room. Across from you, perhaps 3 meters away, is a wall. Light leaves that wall, travels through the air, enters your eye, triggers chemical reactions in your retina, sends electrical signals along your optic nerve, and finally becomes something your brain interprets as wall. That journey takes time. Not much time. Light crosses 3 meters in about 10 billionths of a second. The neural processing adds perhaps 50 to 100 milliseconds on top of that. But the wall you see is not the wall as it exists in this moment. It is the wall as it existed a fraction of a second ago. The difference seems trivial, and in most practical terms, it is. A wall does not change much in a tenth of a second, but the principle remains. You do not see things as they are now. You see them as they were. Extend the distance. Someone stands across a large field, perhaps 500 meters away. They raise their hand. You see it rise. Light has traveled half a kilometer to reach you. A journey that takes about 1.5 millionths of a second. Add the neural delay, and you are watching an event that occurred roughly 100 milliseconds in the past. Still not much, but now consider sound. They clap their hands together. You see the clap, and then, a moment later, you hear it. Sound travels much slower than light, about 343 meters per second in air at room temperature. 500 meters takes about 1.5 seconds to cross. The gap is now perceptible. You watch the hands come together, and then you wait. The sound arrives like a visitor who took the long road. This is familiar. Thunder follows lightning. You see fireworks bloom before you hear them crack. The world arrives in layers, each traveling at its own speed. But even the fastest layer, light itself, is not instant. Think about the moon. On a clear night, you look up and see it, bright and present in the sky. It feels like you are looking at the moon as it exists right now, in this moment. But you are not. The moon is, on average, about 384,000 kilometers away. Light from the moon takes about 1.3 seconds to reach Earth. When you look at the moon, you are seeing it as it was 1.3 seconds ago. The moon has moved since then. Not much, perhaps a kilometer along its orbit. But it has moved. The position you see is already outdated. If the moon somehow vanished in this instant, you would still see it for another 1.3 seconds, shining steadily, oblivious to its own absence. This is not a trick of perception. This is how information travels. Light moves at a finite speed, and distance creates delay. The sun is farther. It sits about 150 million kilometers away. Light from the sun takes roughly 8 minutes and 20 seconds to reach Earth. When you feel sunlight on your face, you are feeling light that left the sun more than 8 minutes ago. The sun you see is the sun as it existed 8 minutes in the past. If the sun were to suddenly extinguish, if some impossible event caused it to stop shining, we would not know for 8 minutes and 20 seconds. The sky would remain bright. The warmth would continue. And then, all at once, the light would stop arriving. 8 minutes is long enough to notice, long enough to feel. You could make coffee in the time it takes sunlight to reach you. You could walk a mile. You could have a conversation. The sun is not immediate. It is distant, both in space and in time. Go farther. The nearest star beyond the sun is Proxima Centauri, about 4.24 light years away. A light year is the distance light travels in 1 year, roughly 9.46 trillion kilometers. When you look at Proxima Centauri, you are seeing light that has been traveling for more than 4 years. You are looking at the star as it was in early 2022, assuming you are observing it now in 2026. 4 years is a significant delay. 4 years ago, you were a different person. The world was different. And yet, the light arriving now set out back then, crossing empty space in silence, carrying an image of a past that no longer exists. If Proxima Centauri exploded tomorrow, we would not know until 2030. The scales grow quickly. Sirius, the brightest star in the night sky, is 8.6 light years away. The North Star, Polaris, is about 430 light years away. The center of our galaxy is roughly 26,000 light years distant. When you look at the stars, you are not looking at the sky as it is. You are looking at a historical record stitched together from light that left at different times. Some stars you see may no longer exist. Others may have formed since their light began its journey, but their light has not yet reached us. The night sky is not a photograph of the present. It is a collage of the past, assembled by distance. The Andromeda Galaxy is about 2.5 million light years away. When you look at Andromeda, assuming you can find it, faint and smudged in the night sky, you are seeing it as it was 2.5 million years ago, before modern humans, before Homo sapiens had fully emerged as a species. Our ancestors then were still learning to walk upright, to use tools, to speak. They had no concept of galaxies, no telescopes, no understanding of light or time. And yet, the light that you see now was already traveling, crossing incomprehensible distances in silence. What you see is ancient, and it is everywhere. Every photon that reaches your eye has traveled. Every image is delayed. The universe does not present itself in real time. It presents itself slowly, patiently, 1 light year at a time. This is the first delay, the speed of light. It is not optional. It is not something that could be avoided with better technology or sharper senses. It is built into the structure of space-time itself. Light moves at about 299,792 kilometers per second in a vacuum. This is not arbitrary. It is a fundamental constant of nature, woven into the equations that describe how the universe behaves. Nothing with mass can reach this speed. Nothing can exceed it. Information cannot travel faster than light, at least not in any conventional sense. The speed of light is a limit, a boundary, a ceiling that governs how quickly one part of the universe can influence another. And because light moves at a finite speed, distance creates delay. The farther something is, the longer it takes for light to arrive. And because we perceive the world through light, through electromagnetic radiation interacting with our senses, we are always perceiving the past. Return to smaller scales. You are in a room again. Someone across from you is speaking. Their words travel as sound waves, compressions and rarefactions in the air, moving at about 343 meters per second. If they are 3 meters away, sound takes roughly 9 milliseconds to reach you. Not long, but measurable. If you were paying close enough attention, you would notice that their lips move slightly before the sound arrives. But sound is slower than light, so you see their lips move first, and then you hear the words. The image and the sound are separated by a small delay, created by the difference in their travel speeds. Your brain stitches them back together. It synchronizes the image and the sound, creating the illusion that they occurred simultaneously, but they did not. The brain adjusts, compensates, hides the delay. This happens constantly. Your experience of the world is not raw data. It is a reconstruction assembled by your brain from pieces that arrived at different times. Touch feels immediate. You place your hand on a table. You feel the surface, solid and present. But even this is delayed. When your skin makes contact with the table, mechanoreceptors in your fingertips respond to pressure. They convert mechanical force into electrical signals, which travel along nerve fibers toward your spinal cord and brain. These signals move fast. Some nerve fibers conduct at speeds up to 120 meters per second, but they are not instant. The signal has to travel from your fingertip, up your arm, along your spinal cord, and into your brain. For a signal traveling from your hand to your brain, this takes somewhere between 10 and 30 milliseconds, depending on the exact pathway. 30 milliseconds is not much, but it is there. The sensation you feel is not occurring now. It is the echo of a touch that happened a fraction of a second ago. Consider a different scenario. You stub your toe on a piece of furniture. For a brief moment, you feel the impact, the pressure, and then, a fraction of a second later, the pain arrives. This is because pain signals travel more slowly than touch signals. Pain is carried primarily by smaller, slower nerve fibers, some as slow as 1 meter per second. If your toe is roughly 1 meter from your brain, measured along the nerve pathway. A pain signal traveling at 1 meter per second takes about 1 second to arrive. 1 full second. You can feel this. You can notice the gap. The impact and the pain are separate events, divided by a measurable delay. Your brain tries to synchronize them, to make sense of the timeline. But the delay is real. The pain you feel now is a record of an injury that occurred a moment ago. Vision is faster than pain, but still not instant. When light enters your eye, it strikes the retina, a thin layer of tissue at the back of your eyeball packed with photoreceptor cells. These cells absorb photons and convert them into electrical signals through a process called phototransduction. The signals travel from the retina along the optic nerve to the brain, specifically to a region called the visual cortex, located toward the back of your skull. The entire process, from light entering the eye to the brain beginning to interpret the signal, takes somewhere between 20 and 100 milliseconds, depending on various factors like the intensity of the light, the complexity of the image, and the specifics of your neural wiring. Let's say it takes 50 milliseconds on average. 50 milliseconds is 1/20th of a second. Fast, but not instant. And this is just the time it takes for the signal to arrive. The brain still has to process the information, assemble it into a coherent image, integrate it with memory and context, and deliver it to your conscious awareness. By the time you become aware of seeing something, the image has already gone through multiple stages of processing. You are not seeing the world directly. You are seeing a reconstruction, assembled by your brain from delayed and incomplete information. This creates a strange situation. Your brain is constantly predicting the present. Because all sensory information arrives with a delay, your brain has to compensate. It has to account for the time lag, to estimate where things are now based on where they were a moment ago. If you are trying to catch a ball, your brain does not simply react to where the ball was when the light from it reached your eyes. It predicts where the ball will be by the time you move your hand. This prediction is happening continuously, invisibly, beneath the surface of awareness. You do not notice it because the brain is very good at it. But occasionally, the prediction fails. Optical illusions often exploit these predictive mechanisms. The brain expects something to behave in a certain way based on past experience, and when reality does not match the expectation, the result is confusion, mismatch, illusion. The brain is not passively recording reality. It is actively constructing it, moment by moment, using delayed information and educated guesses. Here is another complication. Your senses do not all operate on the same timeline. Vision, hearing, touch, taste, smell, they all have different processing speeds. Vision is relatively fast. Hearing is slightly slower. Touch varies depending on the type of sensation. Taste and smell are slower still. And yet, when you experience the world, everything feels synchronized. You see someone clap their hands, and you hear the sound, and it feels simultaneous. But it is not. Your brain is constantly adjusting the timing, delaying some signals and speeding up others, trying to create a coherent, synchronized experience from inputs that arrived at different times. This adjustment happens in a part of the brain that integrates sensory information, and it operates largely outside of conscious awareness. You do not notice the adjustments. You just experience the result. A world that seems to happen all at once. But beneath that seamlessness, there is a patchwork of delays, carefully hidden. Even your thoughts are delayed. Consider the act of deciding to move your hand. You feel as though you make a conscious decision, and then your hand moves. But experiments have shown that the brain begins preparing for the movement before you become consciously aware of deciding to move. In studies where participants are asked to perform a simple action, like pressing a button, and to note the exact moment they decided to act, researchers have found that brain activity associated with the movement begins several hundred milliseconds before the participant reports awareness of the decision. Several hundred milliseconds. The brain is already acting before you know it. This does not necessarily mean that free will is an illusion. That is a much larger question beyond the scope here. But it does mean that the conscious experience of deciding is itself delayed. Awareness of your own intentions arrives after those intentions have already begun to take shape. You feel like you are in control, steering your actions in real time. But the real time you experience is slightly behind the actual timeline of neural events. Your sense of agency is a reconstruction assembled after the fact. Return to the idea of now. What does it mean to say that something is happening now? If every sensation arrives delayed, if every perception is a reconstruction of the past, then what you call now is not the present. It is a moment that has already passed by the time you become aware of it. The present exists somewhere ahead of you, unreachable, always slipping away before you can catch it. What you experience as now is actually a composite, a blend of signals that left their sources at different times, traveled different distances, and arrived at different moments, all stitched together by your brain into something that feels like a single, unified instant. But it is not a single instant. It is a range of instants, smeared across time, assembled into a convenient illusion. This is true at every scale. At the scale of your body, the delay is milliseconds. At the scale of a room, it is still milliseconds. At the scale of a field or a city, it might reach a few seconds. At the scale of the solar system, it is minutes. At the scale of the galaxy, it is thousands of years. At the scale of the universe, it is billions. The farther you look, the farther into the past you see. And there is no escaping this. It is not a limitation of your senses. It is a property of space-time. Distance and time are connected. To be separated in space is to be separated in time. The universe is not a static stage on which events occur simultaneously. It is a sprawling, dynamic structure in which distance creates delay. Consider what this means for the concept of simultaneity. If two events happen at the same time, we say they are simultaneous. But at the same time turns out to be a surprisingly slippery idea. Imagine two events occurring far apart, say a supernova exploding in a distant galaxy and a child being born on Earth. Did they happen at the same time? The question seems simple, but it has no definite answer. From Earth's perspective, if we observe the supernova light arriving now and a child is born now, we might say they are simultaneous. But from the perspective of the supernova, the light left thousands of years ago. From its perspective, the child was not yet born. The events are not simultaneous. In fact, according to the theory of relativity, there is no universal now. Different observers, moving at different speeds or located in different places, will disagree about which events are simultaneous. Simultaneity is relative. It depends on your frame of reference, your motion, your position in space-time. There is no cosmic clock ticking the same now for the entire universe. The present is local, individual, observer-dependent. This is difficult to hold in mind. We are used to thinking of time as a single universal flow, a river that carries everyone along at the same rate. 1 second here equals 1 second there. The past is behind us, the future is ahead, and the present is the thin edge where they meet. But this is an approximation useful at human scales but inadequate for the universe as a whole. Time does not flow uniformly. It stretches and compresses depending on gravity and motion. Clocks at different altitudes tick at different rates. Travelers moving at high speeds age more slowly than those who stay still. And because light has a finite speed, the now you experience is not the same now experienced by someone else, somewhere else. The universe is not synchronized. It is a collection of overlapping, offset timelines, each slightly out of step with the others, return to light itself. Light is strange. From the perspective of a photon, if such a perspective can be meaningfully imagined, time does not pass. A photon emitted from a distant star and absorbed by your eye does not experience the journey. To the photon, emission and absorption are the same event, with no duration in between. This is because, at the speed of light, time dilation becomes infinite. Time stops. Of course, photons do not have consciousness. They do not experience anything. But the mathematics of relativity tell us that from the photon's frame of reference, its journey is instantaneous. And yet, from our perspective, the journey takes time. It can take seconds, years, millions of years. The same event, photon travels from source to destination, has two different descriptions, depending on who is doing the describing. This is not a contradiction. It is a feature of space-time. The interval of time between two events depends on the path taken through space-time, and different observers take different paths. Light travels along a special kind of path, one where time, from its own perspective, does not advance. But for us, watching from the outside, time passes as the light moves. Think about the cosmic microwave background. This is the faint glow of radiation left over from the early universe, roughly 380,000 years after the Big Bang. At that time, the universe had cooled enough for atoms to form, and light was able to travel freely through space for the first time. That light has been traveling ever since. It has been redshifted by the expansion of the universe, stretched from visible light into microwaves. But it is still here, still traveling, filling every part of the sky. When you point a radio telescope at the sky and detect the cosmic microwave background, you are seeing light that has been traveling for about 13.8 billion years. Nearly the entire age of the universe. You are looking at the universe as it was 13.8 billion years ago, when it was young, hot, dense, and nothing like it is now. The light you detect is older than the Earth, older than the Sun, older than most of the stars in the galaxy. It left its source before anything remotely resembling the present universe existed, and yet it is arriving now, gently, patiently, as if to remind you that the past is not gone. It is still here, still traveling, still reaching out across time. This creates a peculiar situation. When you look into deep space, you are also looking back in time. The farther you look, the older the light. The farthest galaxies we can detect are so far away that their light has been traveling for over 13 billion years. We see them as they were billions of years ago, when the universe was young. We do not know what they look like now. We cannot. The light carrying that information has not yet arrived. In fact, many of those galaxies have probably changed beyond recognition. Some may have merged with others. Some may have been torn apart. Some may no longer exist in any meaningful sense. But we see them as they were, frozen in a moment long past. There is something deeply strange about this. The universe is vast enough that distance becomes time. To look across space is to look across history. You do not see the universe as it is. You see it as it was, assembled from light that left at different times, creating a layered, temporal collage. And because the universe is expanding, some parts of it are moving away from us faster than light can travel toward us. We will never see the light from those regions. They are beyond what is called the cosmological horizon, the boundary of the observable universe. The observable universe is not the entire universe. It is just the part whose light has had time to reach us since the Big Bang. Beyond that boundary, there may be more galaxies, more stars, more structure, but we will never see them because their light will never arrive. The expansion of space has carried them beyond reach. The universe is larger than what we can observe, and what we can observe is already outdated by the time we see it. This applies to everything. The moon is 1.3 seconds in the past. The sun is 8 minutes in the past. The stars are years, centuries, millennia in the past. The distant galaxies are billions of years in the past. Even the room you are in is a fraction of a second in the past. There is no present that you can access directly. There is only the past, arriving in waves, each wave carrying information that is already obsolete by the time you receive it. The universe does not announce itself in real time. It arrives softened by distance, delayed by the finite speed of information. Now consider another delay, the delay of interpretation. Even after light reaches your eye, even after signals reach your brain, there is still a gap before you become consciously aware. The brain does not simply relay sensory information to consciousness. It processes it, filters it, interprets it, integrates it with memory and expectation. This takes time, somewhere between 100 and 500 milliseconds, depending on the complexity of the stimulus and the task. Let's say it takes 200 milliseconds on average, 0.2 of a second. That is the gap between the brain receiving information and you becoming aware of it. During that gap, a lot happens. The brain identifies patterns, recognizes objects, predicts outcomes, prepares responses. It does all of this beneath the surface of awareness, invisibly. By the time you become conscious of seeing something, your brain has already decided what it is, whether it is important, and how you should respond. You feel like you are reacting to the world in real time. But you are reacting to a version of the world that was assembled 200 milliseconds ago. This delay has practical consequences. In fast-paced situations, driving, sports, anything requiring quick reactions, your brain cannot rely solely on conscious awareness. There is not enough time. Instead, much of your behavior is handled by unconscious processes, reflexes, learned patterns that bypass conscious thought. You see a ball coming toward you, and you catch it. You do not consciously calculate its trajectory, predict its arrival, and then move your hand. You just move. The calculation happens unconsciously, quickly, before awareness even registers the ball. Conscious awareness arrives later, like a narrator describing events that have already occurred. This is efficient. It allows you to respond quickly without waiting for the slow machinery of consciousness to catch up. But it also means that much of your behavior is not directly controlled by the you that you think of as being in charge. You are not piloting your body in real time. You are receiving reports of what your body has already done. And even those reports are edited. Your brain does not show you everything it processes. It filters. It prioritizes. It highlights what it deems important and ignores the rest. Your visual field, for example, is much wider than the area you pay attention to. Most of your vision is peripheral, blurry, colorless, vague. Only the center of your vision, a small region called the fovea, is sharp and detailed. But you do not notice this. You feel like you see the entire world in sharp detail all at once. This is because your eyes are constantly moving, darting from one point to another several times per second. Each time they move, they capture a sharp image of a small region. The brain stitches these images together into a seamless panorama. The panorama is an illusion, a mental construct assembled from snapshots. But the illusion is so convincing that you do not notice the gaps. You see what your brain wants you to see, assembled from pieces, delayed and edited. There are experiments that demonstrate this. In one well-known study, participants are shown a brief flash of light, followed shortly by another flash. Under certain conditions, the brain perceives the second flash before the first, reversing the order of events. This happens because the brain does not present events in the exact order they occurred. It organizes them, adjusts the timing, creates a narrative that makes sense. If two events happen very close together, within the temporal resolution of conscious perception, the brain has some flexibility in deciding which came first. It uses context, expectation, and learned patterns to make a judgment. The result is that the order of events in your conscious experience may not match the order in which they actually occurred. Consider another example, the cutaneous rabbit illusion. In this illusion, a person is tapped rapidly on the wrist, then the elbow, then the shoulder. Even though the taps are only at 3 locations, the person feels a series of taps hopping up the arm, as if a tiny rabbit were running along the skin. The brain fills in phantom taps that never occurred, creating a continuous motion from discrete inputs. This happens because the brain expects continuous motion. When it receives taps at different locations in quick succession, it assumes something must have traveled between those locations, and it generates the sensation of intermediate taps to match that expectation. The experience is vivid, convincing, and completely fabricated. Your brain does this constantly, in subtle ways, smoothing over gaps, filling in missing details, constructing a coherent experience from incomplete information. Return to the idea of now. If sensory information is delayed, if neural processing is delayed, if conscious awareness is delayed, and if the brain actively edits and reconstructs the timeline of events, then what is the present? It is not a fixed point in time. It is not a moment that all of your senses agree on. The present is a moving target, constantly receding, always slightly out of reach. What you call now is a construction, a narrow window of recent events assembled into something that feels immediate but is actually a blend of multiple delays, each offset from the others. The present is not given to you. It is created by you, moment by moment, from pieces of the past. This is not to say that the present does not exist. It does exist, somewhere. Events are occurring right now, in the actual timeline of the universe, but you do not have direct access to that timeline. You experience a version of it, delayed and reconstructed, shaped by the limits of your senses and the architecture of your brain. The universe is out there, unfolding in real time, but the version you inhabit is slightly behind, like watching a live broadcast on a screen with a few seconds of lag. The lag is unavoidable. It is built into the system. There is a thought experiment worth considering here. Imagine you are looking at a star, and at the exact moment you see it, the star explodes. Did the explosion happen now, or did it happen years ago? From the perspective of the star, it happened now. In the star's own timeline, the explosion is occurring in the present. From your perspective, the light from the explosion will not reach you for years. When you eventually see it, the explosion will be in your past, an event that happened years ago, finally catching up to you. But what about the moment you are looking at the star before the explosion's light has arrived? At that moment, the star has already exploded in its own timeline, but you are still seeing it as it was before the explosion. In a sense, both versions of the star are real. The pre-explosion star is real in your past light cone, the region of space-time from which light has had time to reach you. The post-explosion star is real in the star's timeline, but outside your past light cone. Neither version is more real than the other. They simply exist at different points in space-time, separated by distance and the finite speed of light. This is what relativity teaches, that time and space are woven together, and that separation in space creates separation in time. What is now for you is not now for someone else far away. What is past for you may still be future for someone else, depending on their motion and position. The universe does not have a single universal present. It has a collection of overlapping observer-dependent presents, each slightly different. And because light takes time to travel, you can never see the universe as it is now. You can only see it as it was from various points in the past, layered together into a composite image. This layering happens everywhere, at every scale. When you look at a person across the room, you are seeing them as they were a fraction of a second ago. When you look at the moon, you are seeing it as it was 1.3 seconds ago. When you look at the sun, you are seeing it as it was 8 minutes ago. When you look at distant galaxies, you are seeing them as they were billions of years ago. Every image is a fossil. Every perception is a memory. You are surrounded by echoes. And yet, this does not feel true. When you look at someone, it feels like you are seeing them now, directly, without delay. The illusion is seamless. This is because your brain is designed to create that seamlessness. It is designed to hide the delays, to stitch together the fragments, to present you with a world that feels immediate and coherent. But the coherence is a trick. The immediacy is an illusion. Beneath the surface, everything is delayed. Everything arrives having already traveled. There is no way around this. You could improve your senses. You could speed up your neural processing. You could eliminate every inefficiency in the system. But you cannot eliminate the speed of light. You cannot make information travel faster than it does. And as long as information has to travel, there will be delay. The universe is structured such that distance and time are inseparable. To be far apart is to be separated in time. To perceive something is to perceive its past. This is not a flaw. It is not something that could be fixed. It is the way space-time works. Consider what this means for causality. If you see a distant event, a supernova, for example, by the time you see it, the event has already occurred. The light has traveled across space, carrying the information. But during that travel time, the event could not have influenced you. It was outside your light cone, the region of space-time from which signals could have reached you. Only when the light arrives do you become aware of the event. Only then does it enter your causal past, the set of events that could have influenced you. Before the light arrives, the event might as well not exist. From your perspective, it is happening, but it has not yet affected you. It is causally disconnected. Causality itself is constrained by the speed of light. Events can only influence each other if signals can travel between them, and signals take time. The universe is not a web of instantaneous connections. It is a network of delayed interactions, each propagating at the speed of light or slower. This creates a kind of cosmic loneliness. Every part of the universe is isolated from every other part by distance and delay. No two places share the same now. No signal travels instantly. You can send a message to a distant star, but by the time it arrives, years will have passed. The star may have changed. The civilization that receives the message may be different from the one you were trying to reach. And by the time they send a reply, more years will pass. By the time you receive it, you may no longer remember why you sent the original message. Communication across vast distances is communication with the past and future, never the present. The farther apart you are, the more the conversation is stretched across time. Return to Earth. Even here, on this small planet, there are delays. When you speak to someone on the other side of the world via phone or video call, there is a lag, usually a fraction of a second. This lag is not just from the electronics. Some of it is from the time it takes signals to travel through cables and satellites, crossing thousands of kilometers. Light and electrical signals move fast, but not infinitely fast. They still have to cover the distance. If you are talking to someone on the opposite side of the Earth, about 12,000 kilometers away, light takes about 40 milliseconds to travel that distance. Add in the processing time for encoding, transmitting, and decoding the signal, and the total lag can be 100 milliseconds or more, 1/10 of a second. You notice this. The conversation feels slightly off. The rhythm is broken. You speak, and then you wait for the reply, and the gap is just long enough to feel awkward. This is distance asserting itself, even on a small scale. On Earth, these delays are usually negligible, but as you move farther out, they grow. Communication with the Moon has a delay of about 2.6 seconds round trip, 1.3 seconds each way. Astronauts on the Moon cannot have a real-time conversation with mission control. They speak, and then they wait. The delay is noticeable, disruptive. Communication with Mars is worse. Depending on where Earth and Mars are in their orbits, the distance between them ranges from about 55 million to 400 million kilometers. At the closest approach, light takes about 3 minutes to travel from Earth to Mars. At the farthest, it takes about 22 minutes. A round-trip conversation takes between 6 and 44 minutes. Imagine trying to have a conversation with that kind of delay. You ask a question. You wait 22 minutes. They respond. You hear it 22 minutes later. You reply. They hear it 22 minutes after that. An hour has passed for a simple back and forth. This is the reality of interplanetary communication. It is slow, asynchronous, decoupled from any sense of real-time interaction. Go farther. The Voyager 1 spacecraft is currently about 24 billion kilometers from Earth, more than 160 times the distance from Earth to the Sun. Signals from Voyager take about 22 hours to reach Earth. When Mission Control sends a command to Voyager, they send it and then wait nearly a day to confirm it was received. By the time the confirmation arrives, the spacecraft has moved. The situation may have changed. The command is already in the past. Voyager is so far away that it exists in its own timeline, only loosely connected to ours by faint radio signals traveling at the speed of light. And Voyager is still within our solar system, technically. It has crossed into interstellar space, but it is still gravitationally bound to the Sun, still part of the Sun's influence. Beyond Voyager, beyond the solar system, the distances grow incomprehensible. The nearest star system, Alpha Centauri, is about 4.37 light-years away. A signal sent there would take 4.37 years to arrive. A reply would take another 4.37 years. Nearly 9 years for a simple exchange. By the time you received a response, you might have forgotten the original message. You might have moved on. The question might no longer matter. And this is the nearest star. Most stars are much farther. The delays scale with distance. At cosmic scales, communication becomes almost meaningless. You can send a message, but you will never receive a reply within your lifetime. You are not conversing. You are sending a letter into the void, hoping it might arrive somewhere, sometime, long after you are gone. This is the isolation imposed by the speed of light. The universe is vast, and every part of it is cut off from every other part by distance and time. Information can travel, but slowly. Influence can spread, but not quickly. There is no way to reach out across the universe in real time. There is no way to know what is happening now, far away. There is only the past, arriving slowly, and the future, receding into the distance. Return to the human body. Even here, at the smallest scales, there are delays. Neurons communicate through electrical and chemical signals. When one neuron fires, it sends an electrical pulse down its axon, a long, thin extension, toward other neurons. At the end of the axon, the electrical pulse triggers the release of neurotransmitters, chemical messengers that cross a small gap, called a synapse, to reach the next neuron. This process is fast, but not instant. The electrical pulse travels at speeds ranging from 1 to 120 meters per second, depending on the type of neuron. The chemical transmission across the synapse takes about 0.5 to 1 millisecond. Each step introduces a tiny delay, and the brain is made of billions of neurons, connected by trillions of synapses. Signals have to pass through many neurons to get from one part of the brain to another. Each hop adds a delay. Each synapse adds time. The result is that even within the brain, communication is not instant. Information has to travel, neuron by neuron, synapse by synapse. This creates timing challenges for the brain. Different parts of the brain process different types of information. Vision is handled mostly in the back of the brain. Hearing is processed on the sides. Touch is mapped across the top. Signals from the eyes, ears, and skin arrive at different times and are processed at different speeds. And yet, somehow, the brain synchronizes them. It creates the experience of a unified, coherent world. How it does this is still not fully understood, but it involves timing adjustments, predictions, and a lot of behind-the-scenes coordination. The brain is constantly managing delays, compensating for them, hiding them. Think about this. Every thought you have is the result of signals traveling through your brain. A thought is not a single event. It is a cascade. Neurons firing in sequence, signals propagating through networks, activity spreading from one region to another. This takes time. Estimates vary, but a single thought, if such a thing can be defined, probably involves neural activity that unfolds over at least 100 to 200 milliseconds, and often longer. 0.2 of a second, at minimum. That is how long it takes for a thought to form, to coalesce from the noise of neural activity into something coherent enough to be noticed by consciousness. And even then, consciousness itself is delayed. By the time you become aware of a thought, the neural processes that created it have already run their course. You are always catching up to yourself. There is a strange recursion here. You are made of matter that obeys the same laws as the rest of the universe. The signals in your brain travel at finite speeds. The delays that separate you from the stars also separate you from yourself. You are not a single, unified thing existing in a single moment. You are a distributed process spread across time and space, held together by signals that take time to travel. Your sense of self, the feeling of being a coherent, continuous you, is a construction assembled from delayed fragments. There is no central you experiencing everything at once. There is only a network of processes, each running on its own timeline, sending messages to each other, trying to stay coordinated. The unity you feel is an illusion, created by the brain's ability to synchronize these processes. But the synchronization is imperfect. The delays are real. Consider memory. When you remember something, you are not accessing a recording. You are reconstructing the memory from fragments stored across different parts of the brain. This reconstruction takes time, usually at least a few hundred milliseconds, often longer for detailed memories. And the reconstruction is not always accurate. Each time you remember something, the memory changes slightly. It is influenced by your current mood, your expectations, your knowledge of what happened later. Memory is not a faithful record of the past. It is a constantly updated story, rewritten each time you access it. The past you remember is not the past as it happened. It is a past that has been edited, distorted, and delayed. Even your own history is out of reach, accessible only through imperfect reconstructions. This is deeply strange. You cannot access the present directly. You cannot access the past accurately. You are always working with delayed, edited, reconstructed information. And yet, this is all you have. This is the only way experience works. You are built from delays. You are made of signals that take time to travel, processes that take time to unfold, reconstructions that take time to assemble. There is no escaping this. There is no version of you that exists outside of time, observing the universe in real time. You are part of the universe. You are subject to its laws. You are delayed, just like everything else. What does this mean? It means that the present, the immediate, vivid, tangible now, is an illusion. Not in the sense that it does not exist, but in the sense that it is not what it seems. The present feels like a single, unified moment. It feels like everything is happening at once, right here, right now. But it is not. The present is a patchwork, a collage of moments from slightly different times, stitched together by your brain into something that feels seamless. The light from the wall left a fraction of a second ago. The sound from across the room left a few milliseconds ago. The sensation in your hand was generated a few dozen milliseconds ago. The thought you just had began forming a couple hundred milliseconds ago. All of these are blended together into a single experience, which your brain labels now. But now is not a point. It is a window, a narrow slice of the recent past, assembled into something that feels immediate. And this window is always moving. As time passes, the window slides forward. New information arrives. Old information fades. The brain continuously updates its reconstruction of the present. You feel like you are standing still in time, watching the world flow past. But you are not standing still. You are moving forward, carried along by the same process that carries everything else. The present is not a place you occupy. It is a process you participate in. This has implications. If the present is not immediate, if it is always delayed and reconstructed, then your experience of the world is fundamentally indirect. You do not perceive reality directly. You perceive a model of reality constructed by your brain from delayed sensory signals. The model is useful. It is usually accurate enough to navigate the world, to interact with objects, to communicate with others. But it is not the same as reality itself. Reality is out there, unfolding according to the laws of physics. Your model is in here, inside your skull, assembled from fragments of information that have already passed. There is a gap between the two, a delay, a separation. This gap cannot be closed. You cannot step outside your own perception to see reality as it truly is, unmediated by senses and brain. You are always inside the gap, experiencing the delay, working with the reconstruction. This is not a tragedy. It is simply the structure of experience. But it is worth noticing, worth holding in mind. The world you experience is not the world as it exists in the present. It is the world as it was a moment ago, filtered through your senses, interpreted by your brain, assembled into something coherent. You are living in the past, always slightly behind, always catching up. And the farther you look, the deeper into the past you go. Look at the ground beneath your feet. The light from it is a few nanoseconds old. Look at the wall. The light is a few nanoseconds to microseconds old. Look at the moon. The light is 1.3 seconds old. Look at the sun. The light is 8 minutes old. Look at the stars. The light is years, centuries, millennia old. Look at distant galaxies. The light is billions of years old. Every glance is a glimpse into history. Every image is a record. The universe does not show you its present. It shows you its past, layered and stacked. Closer objects more recent, distant objects more ancient. This is true for everyone, everywhere. An observer on a planet orbiting a distant star would see the same thing. They would see their own star as it was minutes ago. They would see other stars as they were years ago. They would see distant galaxies as they were billions of years ago. And if they looked in our direction, they would see the Milky Way as it was billions of years ago, long before the Earth formed. We are all looking at each other's pasts, separated by light travel time. There is no shared present, no universal now. There is only a collection of overlapping pasts, each observer seeing a different slice of history, depending on where they are and what they are looking at. This is the universe, a vast, sprawling structure of delayed connections. Every part of it is sending signals, and every part is receiving signals. But the signals take time to travel. By the time they arrive, the sender has moved on. By the time a reply is sent, the original sender may no longer be there. Communication is asynchronous. Interaction is delayed. Causality is constrained by the speed of light. Nothing happens instantly. Everything takes time. Return to your own experience. You are sitting here reading this, but the here you occupy is not a fixed point in space-time. It is a moving window sliding forward through time. The words you are reading now left the screen a fraction of a second ago. The thought forming in your mind is being assembled from neural signals that began firing a moment ago. Even your sense of being here, now, is delayed. You feel present, but the feeling is a reconstruction built from signals that are already in the past by the time you become aware of them. You are always a step behind, watching the echo of a moment that has already passed. And this is not a problem to be solved. It is simply the way things are. Distance creates delay. Time creates separation. The speed of light sets a limit on how quickly information can travel. These are not flaws. They are features of the universe, woven into the structure of space-time itself. You cannot escape them. You cannot bypass them. You can only accept them. There is something humbling in this. You are not at the center of the universe, experiencing everything in real time. You are a small, local observer, receiving delayed signals from a world that has already moved on. You are not special in this regard. Everyone is in the same situation. Every observer, everywhere, is working with delayed information. The universe does not reveal itself to anyone in the present. It reveals itself slowly, patiently, one light second at a time. And perhaps there is something peaceful in this too. The delays are not cruel. They are just neutral facts. The universe is not rushing. It is not demanding that you keep up. It is simply unfolding at its own pace, indifferent to whether you are watching or not. The light from distant stars has been traveling for millions of years. It will arrive when it arrives. There is no hurry. The signals in your brain will propagate at the speed they propagate. Your thoughts will form when they form. There is no rushing them. Everything happens in its own time. You are part of this. You are made of the same delays, the same separations, the same slow unfolding. You are not separate from the universe, observing it from the outside. You are inside it, subject to the same rules, moving at the same pace. Your experience of the world is delayed, reconstructed, indirect. But so is everyone else's. This is what it means to exist, to be embedded in space-time, to receive signals from the past, to assemble them into a present that is always slipping away. There is no conclusion here, no final insight that ties everything together. The delays exist. They are everywhere, at every scale. You cannot eliminate them. You cannot ignore them. You can only notice them. And perhaps, in noticing, you become more aware of the structure of experience, the gap between event and awareness, the distance between reality and perception. Perhaps you become more patient with the slowness of things, the lag in communication, the fact that nothing happens instantly. Perhaps you become more comfortable with the fact that the present is always out of reach, always receding, always just ahead of you. Or perhaps not. Perhaps this changes nothing. The delays will still be there, whether you notice them or not. The universe will still unfold, slowly, patiently, indifferent, and you will still be here, receiving signals, assembling moments, living a fraction of a second behind. Look at your hand again. The light from it has already left by the time you see it. The present has already passed by the time you become aware of it. You are watching an echo, and that is all you have ever been doing.